To really get the most out of this course, we strongly recommend that you have Python installed on your machine. Having Python at your fingertips like this lets you understand how to run Python programs, how to install additional Python modules, and how it all comes together. So we'll devote some of the next videos to guiding you through setting up your environment. We'll then use your newly configured Python environment to run Python scripts locally, discover how to organize code into different files, and talk about what code editors are for and how to choose what tools to use. After you get set up and familiar with your environment, we'll dig deeper into some automation concepts. In the introductory course on Python, we talked a lot about automation. We saw some automation examples and spoke about many possibilities that come with learning to program. In this course, we'll keep expanding on that base. We'll learn how to decide whether to automate something or not, and what it takes to put automation into place. To put this into practice throughout the course, you'll be running Python scripts on a remote Linux machine using Quick Labs. This tool lets you experience real-world scenarios that simulate programming problems you'll likely have to tackle in an IT job. If at any point along the way you feel lost or confused, don't panic. You can watch the videos as many times as you need to let the concepts sink in. Plus, you can ask questions in the discussion forums, which is one of the best ways to find extra information and to connect with other learners. So, we've got a lot to cover. Let's get started. In this course, we'll interact with the operating system a lot. So before we deep dive into more complex concepts, let's do a quick rundown of what we mean when we talk about the operating system, or OS for short. The operating system is the software that manages everything that goes on in the computer. It reads, writes, and deletes files from the hard drive. It handles how the processes start, how they interact with each other, and how they eventually finish. It manages how memory gets allocated to different processes, how network packets are sent and received, and how each program can access the different hardware components. Basically, the OS is a total boss and doesn't mess around. There are actually two main parts to an operating system: the kernel and the user space. The kernel is the main core of an operating system. It talks directly to our hardware and manages our system's resources. As users, we don't interact with the kernel directly. Instead, we interact with the other part of the operating system called the user space. The user space is basically everything outside of the kernel. These are things that we interact with directly, like the system programs and user interface. So when we say operating system, we're referring to both the kernel and the user space. The operating system does a lot of things. It does so much that we need a bunch of courses to cover all of it. But for this course, we'll focus on managing files and processes on the OS running on your computer. The scripts we'll write will all run in the user space. In some cases, though, our scripts may interact with the kernel of the operating system to get extra information or to ask it to perform certain operations. As you probably already know, there's a lot of different operating systems out there. The major operating systems used in IT today are Windows, MacOS, and Linux. The Windows operating system is developed by Microsoft and is widely used in the business and consumer space. Most PCs come with Windows as the default operating system. macOS is developed by Apple and is mainly used in the consumer space. If you purchase any Apple computer, it'll come with macOS preloaded. Linux is an open source operating system. Open source software is free to share, modify, and distribute. Score. Linux is used heavily in business infrastructure. Most servers in the world today are running Linux. It's also available in the consumer space, although less common. Linux itself is actually the name of the kernel originally developed by Linus Torvalds, also a total boss. Because of the evolution of the rest of the operating system, we typically use Linux to refer to both the kernel and the whole operating system. Today, Linux has grown into a huge community effort, with developers all over the world contributing to its success. Because Linux is open source, a lot of different organizations package their own versions of it, unlike Windows or macOS, which are solely developed by their respective companies. We refer to these different flavors of Linux as distributions. Some common Linux distributions are Ubuntu, Debian, and Red Hat. If you've heard of Chrome OS, you may know that it's another operating system based on the Linux kernel. But unlike other distributions, Chrome OS is usually considered an OS in its own right. Lastly, The Android operating system, which is used a lot on smartphones, also runs a Linux kernel. You may have also heard of Unix. Unix is an operating system developed back in the 70s by Bell Labs. After its original release, the OS went through a bunch of different versions with different companies releasing variants of it. The fundamental ideas of how Linux works today are based on the Unix principles. And a lot of the tools that we use to interact with the operating system are open source versions of those originally developed for Unix. This is why these tools and operating principles are usually referred to as Unix, even though the OS we're using is called Linux. So Linux created Linux, which is based on Unix. It's basically a programming tongue twister. Try saying it 10 times fast. The macOS kernel and some of its user space are also based on a kernel and user space tools from the Unix family, known as BSD. So although the graphical interface is extremely different between the two, the command line is actually pretty similar. Like we said earlier, in this course, we'll use Python to interact with the operating system. Python is a cross-platform language. You can use it on Windows, macOS, Linux, and even lesser-known Unix variants like FreeBSD. It's even available on mobile phones. Since it's cross-platform, we can use the same Python code to get to our goal on any operating system, whether the goal is opening files, processing text, or managing running processes. This makes Python a great tool for IT specialists who need to interact with different operating systems. You can apply the skills that you learned from one platform to all the others. So how helpful is that? As we called out before, for the exercises in this course, we'll be practicing with Linux computers. We've chosen Linux because it's the industry standard when it comes to servers that are managed remotely and through automation. When it's relevant, we'll also talk about how the same concepts will apply to Windows or macOS. In my job as a sysadmin, I mainly work with the Linux operating system. I grew up using Windows computers and interacted with them through the graphical interface. The very first time I used Linux was when I was a teenager and my PC crashed. It wouldn't boot up into the user environment. I had a lot of different files and docs I didn't want to give up. So I did some research, and on a friend's computer, I burned a portable Linux OS called Slacks onto a CD. I got my PC to boot up from there and was able to rescue most of my files. Learning Linux opened up a whole new world of customization and configuration for me. When I first started, I found it really interesting, intriguing, and even a little bit scary. Today, Linux is the primary OS I use to work every day. We've learned a bunch of things about operating systems and their histories. If all those different names are making you feel like your human operating system is crashing, don't worry. You'll pick it up as we go along. They say that the best way to learn is to practice, 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 and then practice some more. So we encourage you to practice the exercises in this course by running the scripts on your computer. Doing this will help you hone your programming skills as much as possible and can spark new ideas of things that you could do through programming. As an IT specialist, it's important to know how to install and uninstall software in different operating systems. To run Python locally, you need to have it installed on your computer. We'll give you some pointers in the next videos on how to do this for Python, but we also encourage you to research how to manage your platform on your own. If you feel like you can use a refresher on how to do some basic operations in your OS, like installing packages or running commands, I recommend you take the course Operating Systems and You, Becoming a Power User. This course is taught by my colleague, Cindy, and can really help you get up to speed on OSs. You'll find a link to it in the next reading. As we said in the last video, you can use Python on all major operating systems. So it doesn't matter if you're running Windows, macOS, or Linux, you should be able to run Python locally on your computer. It may even already be installed with your system. To check whether you already have Python installed on your computer, open a terminal or command prompt and execute the Python command, passing -- version as a parameter. Depending on what's installed on your computer, there's a bunch of different things that can happen. It could say it doesn't recognize the command, which means you don't have Python installed. It could return a version that starts with the number 2, which tells us that you have it installed, but it's Python 2. Or it could return a version that starts with the number 3, which means, you guessed it, you have Python 3 installed. For this course, we'll be using Python 3. Some of the things we'll cover are the same on Python 2 and Python 3, but some can be pretty different. So make sure you have Python 3 installed. If running Python -- version returns a version starting with 2, try running Python 3 -- version. Your computer could tell you that the command isn't present, which means you'll have to install Python 3. Or it could return a version that starts with the number 3, which means you already have Python 3 installed. In the next few videos, we'll talk about how to install and set up Python on each operating system if it's not already there. After checking that you have Python 3 installed, we'll also learn about installing additional modules that aren't part of the Python standard library. You'll need these additional modules for some specific exercises in the course. What are these additional modules that we were talking about? In the Intro to Python course, we talked about the Python standard library. This comes as part of the Python installation and includes modules for the most common tasks you can do with Python. But there's tons of other things you might want to do in your scripts, and not all of them are in the standard library. This is where external modules come into play. We can use external modules for a bunch of tasks, like generating PDFs, serving web pages, creating compressed files, interacting with email, and a load of other things. So, how do we find what modules are available? When developers write a Python module that they think others might find useful, they publish it in PyPy, also known as the Python Package Index. We can browse this repository of Python modules to find the module we need. It includes thousands of projects which are classified by different categories, like topic, development status, and intended audience. These external modules are generally managed with a command line tool called pip. This is a cross-platform tool, so you can use it to install, update, and remove external modules on whichever operating system you're running on your computer. Next up, we're going to talk about installing main Python packages and installing external modules on Windows, macOS, and Linux. These videos are all optional. You can watch the ones most relevant to you. Or if you have Python already installed in your computer and you already know how to install external modules, feel free to skip ahead. Windows computers don't usually come with Python pre-installed. To check if your computer already has Python installed, run the command we talked about earlier, python -- version. Nope, no Python here. Python isn't installed on this computer, so we'll need to install it. There are a bunch of ways to do this on Windows. We can download the installable package from the official website and install that one, get it from the store if we're using Windows 10, or we can use a package management system called Chocolatey to manage the installation. For this video, we're just going to install the package from the official website. But if you'd like to get a taste of Chocolatey, you can check it out and download it on your own, because who doesn't like things a little extra chocolatey, right? To find the installer, go to the official download page for Windows. On this page, we can download the executable installer for the Python 3 64-bit architecture. Most computers today are installed with 64-bit installations. So, if you don't know which one to pick that one, unless you know for sure that your computer is running a 32-bit installation. Once the executable installer has downloaded, we want to run it. This will install a new software on our machine, so we need to run it as the administrator user. Before clicking Install Now, make sure you click on the Add Python 3.7 to Path box. The path variable instructs the operating system to look for executables in certain directories of our system when running commands from the terminal. We want to have that box selected so that Python interpreter gets executed when we invoke it from the command line. Great, it's installing. It might take a moment. Now that it's done, we can test to see if it worked. We do this by opening a new PowerShell and executing the same command as before. Nice! We now have an executable Python interpreter that we can use for testing the scripts that we write. As we called out, just because we've got Python 3 installed, it doesn't mean that we have the modules we might need for every possible script. Let's say we're tasked with writing some automation that extracts information out of a website. To get the contents of a website from Python, we can choose the request module, which is used for interacting with web services. First, let's check whether we have this module already available. Darn, the interpreter tells us that the module isn't available. Let's install it using pip. To do that, we'll call pip install requests from the command line, not the interpreter. Ah yeah, we've now got the module installed. Let's try to import it again from the interpreter. Awesome, it worked. And just to double check that, let's try to do something with this module. For example, we can use the get function to get the contents of a website. So the get function processed the website and the response object now has its contents. We can do a bunch of things with it. How about we check the length of the response text using the len function? Fantastic. Now that we have Python set up on our Windows environment, we are ready to have some fun with it. Feel free to explore on your own and try some things out. By default, macOS ships with a version of Python installed, but it's Python 2, not Python 3. Let's check this out. So while we have Python installed on this computer, it's only Python 2. I wonder if we have Python 3 installed as a different command. Let's check. So we don't have Python 3 installed in this computer. Let's install it. There are two ways to install Python on macOS. We can either download the installable package from the official website and install that one, or we can use a package management system called Homebrew to manage the installation. For this video, we're going to install the package from the official website, but feel free to check out Homebrew on your own. To install Python on macOS, go to the official Python page at python.org. Now we'll click the Downloads menu. Because we're running this on a macOS computer, the website will automatically offer us a link to install Python 3 for macOS. We're now downloading the Python 3 executable installer for macOS. Once it's done downloading, we'll execute it, go through the license and terms of use pages, and finally install it. Depending on how your machine is set up, you might need to enter your password to perform the actual installation using administrator rights. Cool! Now we have an executable Python 3 interpreter that we can use for testing the scripts we're going to write. Let's check that it's working by executing the same command as before, python 3 -- version. Great. Now we have Python 3 installed. Like we said earlier, just because we have the interpreter installed, it doesn't mean we have all the modules we might need to execute every possible script. Let's say we need to write an automation script for handling event scheduling. To do that, we need to manage a bunch of different dates and due date operations, like calculating what date it will be in 2 weeks. To make our lives easier with all of that date manipulation, we could use the arrow module, which makes it simple to handle lots of different dates. First, let's check whether we already have this module available. Misfire. The interpreter says there's no arrow module available. To get that module, we'll install it using pip3 command. Notice that on Windows, the command was called pip. On macOS, it's called pip3. So to install the arrow module, we'll call pip3 install arrow from the command line, not the interpreter. Now that we got the module installed, let's try again to import it from the interpreter. Nice. Looks like that worked. To check that we can use it, let's try to do something with this module. How about we use the get function in the module to create a date object from a string? Great. Arrow parsed a date from the string in the format we told it to use. And now the date object has that date. We can now operate with this object. For example, we can ask to increment it by 6 weeks using the shift method and then print it using the format method. The format method that we just used can receive a bunch of parameters. These parameters let us intuitively format the string that we print. We've got our macOS environment ready to go. Now we can use Python and start having some fun with it. Feel free to explore on your own and try some other things out. Up next, I'll show you how to install Python on Linux. You can check that one out, or you can skip ahead. It's up to you. If your computer runs Linux, chances are extremely high that your distribution comes with Python already installed. You can check to see this by opening a terminal and running a command like this. Okay, we have Python installed, but as we saw with macOS, it's Python 2. That's an old version of Python, and we want to use Python 3 instead. Let's check whether we have that. Nice! Python 3 is already there. In some Linux distributions, the Python command may already be using Python 3. In other distributions, like this one, you may need to use Python 3 as a command to access Python 3. In all of these courses, we'll be using Python 3, so make sure that you run the right command for your distribution. If for some reason your Linux installation doesn't have Python 3 installed, you'll need to have it installed using the package management system. The name of the tool to manage local packages will depend on the distribution that you're using. It's called apt on Debian, Ubuntu, and Linux Mint, yum on Red Hat or CentOS, and DNF on Fedora. If you're not sure what the right command is for your distribution, it's a good idea to do a little research to find out. We've included a pointer to more information in the next reading. While our computer here has Python 3 already installed, we still might not have all the modules needed to execute all of the scripts that we'll write. So we still need to learn how to add these modules to our system to make the most out of our Python installation. In this example, we'll be using an Ubuntu computer and the apt tool to install Python packages. We'll talk about two different ways of installing packages. First, through the package management system, and second, through pip. As we said earlier, Linux distributions usually have a package management system, and it's a good idea to use it to install additional software on your computer. Distributions usually include separate packages for the different Python modules available. Say we're tasked with writing some automation software that resizes images to fit a specific size. We could accomplish this by using the Python imaging library, known as PIL module. This includes a ton of image manipulation functionality. To install this module on your Ubuntu computer, we can use the apt tool to install Python 3-pil package. One of the advantages of using the package management system to install packages is that we can set the system to automatically upgrade to newer versions. The package management system makes sure that any dependencies are also installed so that the module is ready to use. So let's check out this module that we just installed. The PIL module is very large because it includes tons of things that we can do for images. For this example, we want to open an image and check its size and format, so we've imported the image submodule inside the PIL module. Now, let's open a file in our home directory using the open method. Great, we've opened the image. Now we can check its size and its format attributes. Okay, the module's working properly. In this case, we wanted a module that was provided by the package management system, so it was easy to just install it using apt. In other cases, we may want to install module versions that are newer than the ones provided in the distribution, or that are not even present in the distribution at all. For cases like these, we can use the same command we mentioned for Windows and macOS, the pip command. For this scenario, we first need to make sure that we have Python 3 version of pip, which is called pip3 and is provided by the Python 3-pip package. We'll do this by installing the package through the package management system. This might take a minute. Now that we have pip3 installed, we can solve problems using a wide range of external modules. For example, imagine that you're tasked with creating an automation that processes the error log from our web service and then generates statistics on the amount of errors or when the most errors occur. To do this kind of data processing, we could use our cutest sounding module yet, pandas, which is widely used in the data analysis field. All right, we have the pandas module installed. Let's try it out with some sample numbers. Okay, we've imported the module. To state the obvious, since this is a tool for data analysis, we'll need some data to use it. Let's generate a few sample lists for the data associated with our website. How about a list of the amount of visitors we've had in the last 5 days? Let's add another list with the amount of errors generated during the same 5 days. Now that we have these two lists, we can use them to generate a data frame, which is the main structure used by the pandas module to do data analysis. So we'll generate the data frame with the lists, adding the days of the week as indexes, like this. With this, we have a data frame that we can use for operations. For example, we can print it in a nicely formatted way. It's always fun to print stuff, but that's not really data analysis. The pandas module allows us to operate on the numbers of each column. For example, we can calculate the mean or average value of one of the columns using the mean method. Nice! We now know how to install Python modules on Linux using either the package management system or pip.
Congratulations on finishing this lesson in the Google IT Automation with Python certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.